welcome to this progress report session. I'll hand it over directly to Maria, who will be chairing this session. So Maria, over to you.
Thank you. So what do you have to do here in the session? And we will ask for one or two members of the team, you choose that, to explain us briefly and also to the other teams how you are doing. Also, you can enter in details, in which things you have been working this morning, to give a bit of information of how it's going. Also, you can ask if you have any problem or something you will need help, and we will try or either to help ourselves or to find someone that can help you with your problems. And also, we will ask you to tell which, now that we are more or less in the middle, you will have more or less an idea of the product or of the final thing you will be able to reach. So to give us an idea in which point you are and how far are you able to be. Also, if someone want to give a comment about a question that the team has, or also to ask short questions, we will allow that. So I think ethereal antimatter can start. Or does anyone has a question right now? No. So someone of ethereal can Philip.
I can go.
So yes, tell us briefly where have you been working on, how is your project doing, and also you can go really into details if you want. I think we can do maybe 5 minutes,
Sure.
and
I
then
think
if you
that's
have
more than enough.
questions.
Yeah.
Perfect.
So, hello everyone. Basically, what our team has done so far is it's something that we said in our video. We wanted to convey 3 messages from about antimatter, and we want to do that using 2 prototypes of interactive exhibitions with the audience. And we've chosen already what are those two exhibitions. One of them will mostly be an interactive game in which we can have, so it will be based on, it will be a coded game, let's say, in which you'll have a universe that you can create particles and antiparticles, and you can change the electric field, magnetic field, see how they interact, see how they behave, and then test a couple of the interactions that can happen between both. The second exhibition is we chose to go for the annihilation of antimatter and matter. So how those two also interact, and it will mostly consist of a table in which we'll have a couple of shapes or pairs of shapes actually. So each pair will have like a positive or a regular image or a regular shape, and the second one will be a negative of that initial shape. And this is to take the user to this table and see if they can have this physical approach to using these shapes and these pieces where they can overlap both the positive and the negative, and see how that interaction leads to a cancellation of the image, let's say. So this allows us to show how annihilation works. It's supposed to be easy to access and to just go onto that type of interaction, where has the first thing that I mentioned is a little bit more in depth. People can learn a little bit more and see how the behavior of matter and antimatter actually goes a little bit further than annihilation. This is where we are right now. We've have both ideas. We've split the team into these to work on these 2 prototypes. We have already some coding going on for the first one, the main game, and we have some drawings, some schematics, and also some user experience studies on how to work with the second one. This is what we've done. And regarding where we will go or how far we will go, we hope to have a somewhat working prototype of the interaction game, and at least also the concept, the finalized concept of how the table with the annihilation behavior would work as well. That's basically it. If any of my team wants to comment on that as well, if I forgot anything, let me know.
Perfect. It's something that you are struggling so far, or that you don't know in which direction to go, and you need maybe help of an expert?
I think at this point in time, we more or less know where we want to go and how to. I know that in terms of coding, my colleagues have mostly worked with solving the problems through Google and so on. So I think we don't need any specific help from mentors at this point in time.
Okay, perfect. But don't forget, if you need it, you always can ask Omar Termost.
Yeah, thank you.
All right. Anyone has any points to add of your team? No? Perfect. So now maybe volunteer generator can continue.
Hi, sure. So what we've been up to. So we've had two elements to ours. One of which is we wanted to build a prototype website, which basically acts as a way, would give an example of a way in which volunteers can come. Think of it like a portal where, imagine you're a volunteer and you want to, you've heard about all these interesting events, but you don't know where to find these events. And ours is a portal where you could come. You could say, I am a volunteer. I have 2-3 hours a week, or I'm free this weekend. Are there any events that I could help with? And then they could input this in some kind of form, almost like a selector, and then it would display to you the events that would be relevant to what you want to do and what your availability is. From the organizer point of view, you can imagine it kind of works counter to this. You have the ability to, put an event forward, put what type of roles and availabilities you need for this event, and then that would then be presented forwards on the portal to the volunteers. At the moment, we're aiming to build kind of a mock-up of this, because actually getting the functionality of this done in the weekend we feel would be probably kind of more than we could achieve in the amount of time that we've got, but at least an idea of to demonstrate that it's a workflow that would add utility and be useful for people is what that we wanted to demonstrate before putting in the technical work for it. The other component for this is that we're trying to provide materials for, imagine you're an event organizer that wants to organize an event, but you're not very experienced. How do you know what to do? And so to this end, we're producing a bit of, I hate to use the phrase documentation, but we would like to get it in, we're trying to get it in a way that's easily digestible. So rather than being given, a 50-page handbook, it comes in a way that's a bit more approachable and digestible by people. Because if you get a big handbook and say, read that and you can organize it, that's, we want to be lowering the barrier to entry and making it easier for people to do events. To that end, we are currently in the process of designing a marketing campaign to recruit for volunteers for an imaginary event. So watch this space. We will be trying to recruit you soon.
I have a question for you. How are you going to fit the document? You are to complete it by yourself, or do you plan to contact with experts in the matter to give their opinion of how do you have to organize an event? Or
so as part of the run-up to the event, we discussed quite extensively with some of the people that have presented, and also some other contacts that we've had, about what challenges they've had. We focus particularly on both recruiting volunteers and keeping volunteers engaged. So we've had quite extensive discussion and feedback from them about what areas of this they've actually found a challenge. Often we find there's very specific and common things that people have issues with actually achieving, as opposed to just the general. That's why we focused on recruitment and motivation and engagement, rather than just being a blanket. We're not going to be telling people things like you need a venue to do your event, because that's something that's very obvious, whereas it's not so, whereas with volunteers and recruitment in particular, that's something where we can add and give some new insight and for people that are organizing events.
Yeah, I think in this case, it's quite important maybe to have a kind of a survey, so you know the opinion of many people, and you make a kind of a range of what's the important points personally. But it's because it's something that can be controversial, like a few people could go more in one direction, other in other. So maybe it's interesting to have kind of a survey where you can reach a middle point, and also include idea that maybe you didn't think in a previous research.
Yeah, I appreciate that view. I would be interested in doing a survey, but I'm conscious that surveys take time to get information, and
it takes time. It's just that's maybe not for doing in the weekend, but to an idea to have in mind.
I have a question for Hugo. So if I understand correctly, your, let's say, project has two parts. One is volunteer oriented, which would be a portal, could be like a where they make profiles or whatever. But for the weekend, for tomorrow, what you'll have in the best case scenario is a mock-up of what that portal will look like.
Yeah.
And for the recruiter side of things, what you will have is a documentation in a digestible format of maybe, you know, the best things that they can do, or I might call it best practices, but you would probably have a better word for that. What form will that take? What is going to be exactly?
At its most basic form, it will be a document. We would like to get it on the website, as you imagine. If you imagine our website has kind of two headers, which is volunteers, organizers, and under the organizers section, as well as being able to add events, there could also be I guess you could call it tutorials, but there's probably a better name for it. I can't come up with it off the top of my head. But it would be kind of a assistance or best practices, I guess, yeah, for event organizers to help them, essentially. What we in particular, we think that offering like good examples of how you can communicate this, or things that you can use, are really powerful, because if anybody's ever read documentation and tried to implement from it, going from something abstract and a bit theoretical to actually what you do, that jump can sometimes be very difficult. And we find that examples can help with that transition.
Okay. I was thinking maybe one last comment, that, for example, in some volunteer recruitment activities, a lot of engagement happens on social media channels.
Mm-hmm.
So if you would consider, for example, mock social media posts for recruiting volunteers, instead of giving examples, would you consider giving like actual posts with fill in the blanks, like to make it even low barrier to entry, and just like here or something like that?
Watch this space. We may be posting some things on the Matters Most channels after this meeting.
And I'll share in chat with you an event that CERN will be having next year. I don't know if they would be interested in something like this. It's called Sparks. It's happening in September 2021. The launch is this weekend, actually, or has already happened. So I don't know if they would be needing volunteers, but we don't have to wait for the next open days. And this might be something to look into. So you might get some feedback from them as well.
Okay, cool.
Thank you.
Okay, thank you.
Okay, thank you. I think now we will move to the following team, Gravity Fringe.
Yes. Hi, everyone. So we started this morning splitting tasks, basically. And actually, let me give you a recap of our project. I can share quickly my screen. Voila. So as we presented in the video last night, we have a trampoline where we have a black hole, like a hole basically, where spinning balls that are dropped inside this universe are going to fall. And while orbiting around the hole, they're gonna affect the interferometer. That is not exactly this the final setup, but this is the most up-to-date drawing that we have. And then the interferometer will show fringes. And so what we have worked on so far is working on the report to make this prototype buildable, let's say, as soon as restrictions due to COVID are released. And also we're working on the visualization of the data, that is interpreting the data that the interferometer transmits, and on having a projection of the ripples of the waves from the ceiling, basically from some camera on top of the fabric. And so I can show you what we have done. This is how, so on the top here, here we're going to see the fringes due to the interferometer. So this is an actual recording from an interferometer from that Steve in our group built. And on the bottom, we can see the waves basically that is represented, that is captured by the interferometer. And so we have time along the horizontal axis. I hope you can see it. There we go. And this goes on for the duration of the data input. And so this would be screened real time while a visitor is interacting with the exhibit. And I guess that's it as an update. So this is what we're working on. Something we might use help with is with real-time visualization and object tracking in particular. So if any of the mentors is an expert in that, that would be really helpful.
There's one more thing. We're also translating the science behind the exhibit into text for the visitors. Since there will be iPads in the exhibition for the visitors to peruse and get more information, we're translating what's happening into engaging words aimed at different levels for various visitors to accompany our proposal in our report.
And we are also receiving and compiling the feedback we already had on this prototype with various people, with some theoretical physicists, with some people that are used to that. One of the mentors that gave the talk on how to create engaging hands-on experiments, and also this afternoon we will talk with some kids to show them our prototype and see their reaction to it.
Okay, really nice. I think that your idea of getting feedback of people is really helpful and good input to improve your prototype and your idea. Right. It's thing. I will move to other team, and if later someone has a comment to do for your team, we can move to that, but I prefer to continue. The team Time Turner, please.
Yep. Hello. So I'll just share my screen. So we have been, that's us. So we've been taking this model was meant to be designed in 3D. So we've been taking that and then implementing it with 3D. And then we've been adding in the interaction. So that's been a main part of the user front end that we've been developing. We've then taken what our internal view, so this card here with the data, and we've been then building the API and database that's relevant for being able to input information. For the end result, we don't plan that we'll be able to merge them together, so we'll have a walkthrough of how this design works with the data, and we hope to then show the 3D model on a standalone, as well as showing the database and API standalone as well. So that's currently where we're up to.
I have a couple of questions. So the 3D model, from the user's perspective, how do they, I mean, I understand for tomorrow you're planning a mock, but in the longer term, once you have a product, how would they interact? And would this be like kind of on a web browser, or is there some specific software that you need to have?
So yeah, we're using 3JS. So it'd just be on a web. It could be anywhere. It doesn't really matter. It's more the representation isn't in 2D, but you can only mock that showing a 2D representation. So yeah, just as a browser.
Okay. And just curious to know, have you thought about what kind of data streams or what kind of data structure you would need for the representation to work? So is this going to be something that's like a standard data structure that people already use, or something that people would have to input information, or like, I don't know, from Excel or from a timeline? How does this work?
Yeah, so we have the option of a Kanban board. So you have a project, and then you have the tasks associated with that, where it's one way. The other nice thing is that if you could export your Jira data, as long as the database matches up with the relevant information, you could export that into the API and expose that externally as well.
Okay.
I also do have a question. Do you have a plan to improve the user experience and to test how people interact with your platform? Because it may be the case that people, it's not easy to understand, or do you have a plan to test that?
Not over the weekend, as that would require us to. So we need to build the system before someone can test interacting. So it's currently like that's the concept, and we're building that. Then you could test it. Okay,
so I guess you will try to reach the first prototype and then send it to test. Okay, all right.
Yeah.
Do you need any help from anyone?
No, I think we're fine. Thank you.
Okay, perfect. Now maybe we can move to Quantum Adventures.
Hi.
Hi.
Hi, so we're Quantum Adventures. Maybe I'll share my screen and show you what we've been up to. Oh, I can share my secondary screen. Great. So we've been looking at, we're making the balancing game. We've been looking at how to show quantum particles that show spin left or spin right, and looking at those properties. And we have the people who can code, with some help from a mentor, have been making this game. So these are just with random objects, and you put them onto the balancing game. And at the moment, then you get more opportunities to balance. But currently it's very hard to play. So there's some sort of, we've decided that for our first iteration, we're just going to go with...
Rosie, sorry to interrupt you. We just see your CAD model screen. So you would have to either share your other screen or share your window for us to see the rest of it.
Oh, that's weird, because I made that window small. Oh, I see. Oh, there we go. Can you see this game?
Yes.
Yes, no.
Okay. So this is what I was talking about. You get your particles and you put them onto your mobile. At the moment, it's quite difficult to do because of the 3 dimensions. So we decided for this first prototype, we're just going to work more or less in 2 dimensions and work with spin left and spin right and entanglement. We've also had feedback that obviously the science at the moment isn't very clear, so the visuals team is also building like a sort of introduction that will introduce us to what these particles actually are. I think that's basically where we are. We're just there's quite a few things to finesse in the game, so there's quite a few like we need to know how much balance is on the left side and on the right side, so that we know how unbalanced it is and when the game is won. So that's what we're working on.
Okay, thank you. Any point about that maybe you need help or that you are struggling? About what you comment?
You like finicky bits in Unity, but it seems like people are working through the problems as they come in the team, and we're helping each other. So we're making progress. Obviously, we'd like more time, but we seem to be making progress.
Just curious to know, what do you expect to have for tomorrow for the presentation? Is it going to be a game that people can access, or only maybe a presentation of a game that you will show but will not be accessible for people?
So you can access this game right now as I'm playing it. So we already have the infrastructure of a web link that anybody could go to in a browser and play this game, and hopefully by tomorrow we'll have a game that you can win or lose with some sort of introduction about the science. Maybe we have some ideas about improving the user interface to explain the science better. So maybe we could improve in that area, but we're hoping that it'll work tomorrow and we'll have our first prototype.
Okay, cool. So so the access is already in principle available, and you're just gonna make iterative improvements as far as you can go. Great.
Yeah, and we'll have the sort of nicer shapes. Yeah.
Great, thanks.
Thank you, Rosie. Now, Hefty Protons, please.
Okay. Yeah, let me go ahead and quickly share my screen so that everybody can see here what exactly we're doing. Yeah, so basically we'd already split up into some smaller teams earlier, and one of the first things that we were working on was what the kind of larger structure is actually going to look like. So one of our deliverables that we want to have for tomorrow is basically a overall CAD drawing about what exactly this is going to look like. So this is basically the tube in the Science Gateway, so this tube structure that's there, and so we just have this this section of it here to show what exactly it'll look like inside. And right now we built a bit on this central console, that we had earlier, there in the middle of this central console, that's where all the interactives are going to be, all the things that the visitors actually can play around with. The shell of the Proton is what these kind of prong-looking things look like on either side. Those are the actual like scaffolding that you have there for the Proton itself, and for the shell for it, and the projectors that will project the interior of the Proton are on this central pillar that is right here in the middle. So basically on the scaffolding as well, there's a blackout curtain so that the projection actually can show properly, and everything is on rails. We have this concept that we want to periodically accelerate our proton to change the conditions that are inside. And when that happens, there will be a bit of shape change that's happening as well on the whole exhibition. So these portions actually move on these rails, so that you end up with an extended, sort of an extended proton here. To zoom in a little bit about our interactives. So another deliverable that we'll have is basically the setup for our scales. So which will actually allow the visitors then to see these mass discrepancies between the individual quarks and the full proton. And basically, what we'll have here is the quarks and the protons here available that will we basically can set onto this balance here, and we can show that there's only 2% of the or about 2% of the proton's mass is coming from these 3 valence quarks. You can take these quarks from this little bowl right here, and you can put them onto here. And there's a step motor basically in this scale structure that will actually help it move then, so that it corresponds to what the differential masses would be like. We wanted to have something mechanical that would also kind of work with this, but we're having a little bit of technical difficulties with that. So at least we'll have the schematic here as to how exactly that would end up looking like. There's a screen here too that has a scientist that kind of guides you through that then and helps to explain what exactly is happening. Yeah, so that's basically the basic setup here for the scale station. We're considering as well the possibility of having a drawer underneath that also can tell a little bit about the strong force and what exactly, how exactly that works, and how that at first is so difficult to bring apart, and then is easier the distance with the increased distance. And then we also have a basically for our storyline, or how exactly the visitors can work through. We have basically a walkthrough we're developing here with this this software that it can help to build storylines. We have a beginner and advanced version that we're developing here, with the possibility to switch between the two. So if you start with the beginner version, you could then say, oh, I want to have more information, and you can switch to the advanced version. Or if you start with the advanced version, you say, oh, that's too much, you can go back then to the beginner version. And this would also be interlinked with the scale and with the scientists, the video of the scientists that's there, so that basically you have an input and response that comes in with the interactive. So we're working on building that. That's going to be another one of our deliverables. And then also I have here a video of our projection. So this is actually the pairs of quarks and anti-quarks that would be projected on the walls of our big proton. And we also have another CAD model that I want to show you really quickly, that is basically for yeah, there we go. That basically is another proton model that we have available that then can show basically what the layout is of the proton, so that people kind of get the idea as well, aside from them being inside the proton themselves, that they can really see where all the components are, where all the parts are. And we want that interior globe to be kind of like a snow globe, so that people can really see as well that there's a lot that's happening with different quarks, and not just those 3 valence quarks. So we really want to focus on that dynamism right there. But yeah, those are basically what we're working on. We're also wanting to develop a technical report on all of these things. So yeah, that's where we are right now.
Yeah, I see you have been working in many things. Thank you for the update. Do you have any help you need from any mentors or anything?
We're getting a lot of help right now from our mentor, and especially with the animation, yeah, and also with the concepts here about the setup for the scale. I think that right now we're all right, but yeah.
Perfect.
I have a question.
Yes.
You have a lot of different proton model concepts all over to represent that information in many ways. I assume that the storyline that you have in Twine will be used to reconcile how the visitor journeys through. Is that the idea?
That's the idea.
And then a quick comment on the snow globe idea. I think that's a brilliant idea. I don't know if you've already considered that the tube at the bottom, if you keep your 3 quarks inside that snow globe, for example, ping pong balls, and you introduced pressurized air into that globe and make the quarks swirl around, then you can show that the quarks are actually moving continuously rather than stationary. So you would be able to represent that. I don't know if you already considered that, but that would be a very interesting way to show traveling quarks inside a stationary proton. That's
okay, great. Thank you.
Hamid?
Yes, Sonia?
Yeah, no, I wanted just to add to Samid's comment. This, in case this pressurized air is going, of course, not in a smooth way, could also show that each quark, when the proton receives energy, the quarks do not receive exactly 1/3 of energy, which could explain, for example, the LHC collisions. Because they are not moving in a smooth way. So they receive random energy from this air, and this could be used also for other things. So this is a good idea.
That's a great idea. Thank you.
Okay, perfect. So now we go to the last team, if I am not wrong, with Particle Silo.
Hi, so let me just share my screen to give you an update. Okay. Yeah, so we've set up the website, the basic website that we're going to iterate with and play with. So it has the basic features that we're planning to deliver tomorrow. And so far, we've split up the team, the entire team, into different subgroups. There's a design team that's focusing on adding some more images to improve the aesthetics of the website. And then there's the back-end team that's working tirelessly on the database so that people can, like the community could add materials to the website. So far we have this website, and if anyone wants to contribute, they could either go to GitHub and then directly fork this repository, and there are some instructions on how to contribute. And then so far, our backend team is also working on the additional features, such as creating an account for different users and also integrating some, making the forum as well. So yeah, that's I think that's all for our update. And for the biggest problem that we have tonight, the biggest challenge is that we want to integrate the back end and the front end, and hopefully we'll be able to do it on time and figure things out.
Okay, perfect. For the update, anyone want to make any comment or to add anything else? So
say something. I think it's really cool that you're using Invenio and powering it with open science. One of the pre-hack speakers, Kamran Naeem, you could get help from him if you want to get more people to contribute through the GitHub repository. He might be able to get more people who are involved in the sorry, I'm losing my words. More people who are involved in the IT infrastructure for the open science to contribute to this initiative. And secondly, since Invenio is one of the CERN knowledge transfer software, you could also get in touch with CERN knowledge transfer, which might help you to continue this project and potentially even help you find funding for this in the future.
Yeah, thanks so much. Yeah, we plan to communicate with those people. What was the name of the guy you mentioned earlier? The guy before you mentioned the CERN knowledge transfer group?
Kamran Naeem, I'm writing that. He's one of the mentors for PsyContact as well.
Okay, all right. Thank you so much.
okay, I think I didn't forget any team. If I did, please talk now. Thank you.
There is one thing before we go. Will please ask everyone to turn on your video so we can take a screenshot for the.
I was about to ask that.
Okay, sorry.
And meanwhile, one announcement: we will publish the guideline of the things we will request in the final pitching session at 5:30 in the announcement channel in Mattermost. So please give a look to that, because there you will find the points you should add in the final pitching. All right, Sonia, it's all right for you?
Yes, I don't have a complete pages with screenshot. Let me take a few more. So I'm page 2, page 1. I go back. Maybe now it's complete. Yes, this is complete now. Please smile. Don't be sad. You are tired, but smile. Okay, we should seem to be happy. Okay, thank you very much. Okay, I think it's should be okay.